In this lecture, we shall be studying about differential equations. The subject of differential equations, it is quite a large subject and it is also an important branch of mathematics. This subject is of great theoretical research and lot of practical applications are based on differential equations. So, where and how do differential equations originate? This is the first question, and what are their uses and why we are basically studying these differential equations. So, to understand this terminology, we shall see the operator form. So, if we understand that x represents the input parameters and any physical phenomena is represented mathematically by the operator k, then we have certain outputs when we apply this operator k onto the inputs x. So, usually this operator k has in mathematical form could either be represented by derivatives, integrations or some other mathematical function, right. So, that means we also have as a operator k the differential. So, whenever there is a change in some physical quantity, differential equations come into picture. So, how can we say that? For that we have to look for certain examples. So, let us proceed on to seeing our first example. So, first example includes population growth. So, suppose someone wants to study about population growth and how it increases. So, here we can see there is a change in the population occurring. So, if we represent by x the population at a certain amount of time. So, for that, for defining a differential equation, we basically need a law. So, the law for natural growth, it states that the rate of population is proportional to the amount of population at that particular time. So, this mathematically could be written as dx by dt is proportional to x, where this dx by dt represents the change in population with respect to time. So, if we wanted to get rid of this proportionality sign, we have to introduce the proportionality constant k. So, we replace the proportionality sign with equation equal to and with k. So, dx by dt is equal to kx, that represents your differential equation. The second example, it includes radioactive decay. So, here the law for radioactive decay, it states that the rate of decay of a radioactive material is proportional to the amount of material present at any particular time. So, if we represent the radioactive material by the symbol U, so the rate of change is represented by du by dt. So, this du by dt is proportional to U, and with time it is obvious that the radioactive material will decay. So, it will when we remove this proportionality sign over here, we have minus some constant. So, here in this case the differential equation would be du by dt is equal to minus k u. In the third case, we have a differential equation when we are studying a LCR, electrical circuit. So, this electrical circuit, if we look at the diagram above here, consists of a resistor represented by R, a capacitor represented by C and an inductor represented by L. So, we all know by Kirchhoff's law, if we wanted to equate the voltages given by that of the battery and that corresponding to each of these components, then using Kirchhoff's law, we have that the sum of voltage drop across all the elements, that is equal to that provided by the external source. So, if the voltage provided by external source is represented by capital V and the voltage drop across resistor, capacitor and inductor are represented by L d square q by dt square. Here q is the charge flowing through the system, t represents time, L is the inductance, R is the resistance, C is the capacitance. So, these three represents the voltages across these three materials, and when we add all of these, we have it equal to the external voltage applied to this. We have already studied all these examples, but here we should note that the equation represented here is a differential equation. So, you see whenever you have some electrical circuit also you have a differential equation in that case. So, formally we can define an equation, differential equation, by stating that it is an equation which includes derivatives of one or more dependent variables with respect to one or more independent variables. So now notice here we have two terms, one is dependent variable and another one is independent variable. So what is this dependent and independent variable? So in order to understand that, let's take an example. Suppose with respect to time, if I wanted to check whether a student is studying or not, and if that student is studying, how much they are studying, that is governed by independent and dependent variable. So independent variable in that case would be time, and dependent variable in that case would be how much the student is studying. So you see, mathematically also, whenever we represent any function, so if we have the equation of this kind, y is equal to f of x, in that case x represents independent variable and y represents the dependent variable. So based on the independent variable, if we have one independent variable, we have the differential equation, namely the ordinary differential equations, also known as ODEs. And whenever we have more than one independent variables, our differential equation is the partial differential equation, which is known as PDEs, right. So we can see the example of ODEs and PDEs here. So in this case, if you look at the ordinary differential equation here in this case, so you have d2x by dt2 plus 9x is equal to sin t. So this represents ordinary differential equation. So here the derivatives are represented by d2x by dt square. And notice in partial differential equation, instead of writing d, we are writing the symbol curl or del, pronounced sometimes. So in that case, you have del 2u by del x2 plus del 2u by del y2 is equal to 0, right. So here u in the second equation is the dependent variable, and independent variables in the second equation is x and y. In the first equation, dependent variable is x and the independent variable is y. So you should differentiate between these, and based on that you have ordinary and partial differential equations. So here we shall be focusing on ordinary differential equations. So now, given a differential equation, what does one do with it? Or we can say, how does one get meaningful results through the differential equations? So basically one solves a differential equation. So how can we solve the given examples that we discussed previously? So let's see how we can calculate the solution to these examples. So in the first case, our differential equation was dx by dt is equal to kx. So here we have derivatives. So in this case, when you solve this, you wanted to calculate what is x corresponding to this differential equation. So we wanted to get rid of these derivatives. What is the obvious answer? The obvious answer is you integrate the given equation. So in the first case, what we do, we separate the variables. That means we move all the x terms to one side, all the t terms to other side, and then we perform the integration. So when you perform the integration of dx by x, that would be log of x, and when you perform the integration of k dt with respect to t, it would be k into t. And moreover, because we are performing indefinite integration, so we also have a constant of integration which we call by a. So from here, if we take log on both sides, or in order to remove x and get the expression of x explicitly, what do? We take the exponential power on both sides. So our final answer would be x is equal to b e to the power k t. And similarly, we can also calculate the solution to this equation, du by dt is equal to minus ku. In this case, we again move with the same process by integrating. However, in this case, we have constant b and k. So let's see how can we determine these constants, because finally we would require the exact value for the unknown variable, that is u in this case. So in order to solve that, we require the initial conditions. So by initial condition, we are given the value of u at some initial time. So initial time in this example is taken to be t is equal to 0. So we say at t is equal to 0, we know how much amount of radioactive substance is present with us. So let's say that to be u naught. So its solution would be obtained when you substitute t is equal to 0 and u is equal to u0 in the above obtained solution. So you obtain the value of b to be u0 and then substitute that value back into the equation. So you have the answer u is equal to u0 e to the power minus kt. So this is the solution. So we saw that we could solve the differential equation by performing simple integration, but not in every case we can perform that integration. So, apart from simple integration, what else could be done here? So, in the subject for differential equation, we have several methods based on the classification of different differential equations. So, that means for a particular kind of differential equation, we have a particular kind of method, and by classifying which the particular differential equation into a particular category, we can then select a method, and with the selected method we could solve the solution. So, before moving on to seeing various methods to solve the solutions, one should be clear with the different classes of differential equation that we have, so that once you are given a differential equation at random, so first of all you see the components and then you classify that differential equation into a particular quantity, and then based on that class of differential equations you select the method which should be applicable onto that particular kind of differential equation. So, the first classification we have already seen, it is ODEs or the PDEs, depending upon the number of independent variables, depending upon the order. So, first of all I am talking about the order of differential equation. So, first of all let us understand what is the order of a differential equation. So, when we talk of order, we say what is the highest order derivative present in the differential equation. So, the order of that highest order derivative which is present in the differential equation is known as the order of the differential equation. So, we can understand and by this through several examples. So, here in the first equation you see this is of second order. Why? Because the highest order derivative is of order 2, right. We have second order derivative present in this differential equation. In the second equation, the highest order derivative is the fourth order derivative present in the differential equation. So, in this case we have it to be of differential equation to be of the fourth order, right. And in the third case, both the derivatives, although they are partial derivatives, both the derivatives they have the first order. So, we classify this equation to be of first order. And in the last equation we have all the three derivatives having order 2, right, which is the maximum order of derivatives available in this differential equation. So, therefore, the order of this differential equation is 2, right. So, having understood various orders, the order of the differential equation, we have differential equations of first order, second order, third order, and similarly we can also define differential equations for higher orders as well. Now, based on this apart from this order, we also have a classification which is defining as linear which defines the differential equation as linear or non-linear equations. So, when do we call a differential equation as linear? So, whenever some equation has in this case our focus should be on the dependent variable, which in most of the cases we take to be y, right. So, in that case the dependent variable y, it should have no powers, that means the power should be 1. Moreover, it should not be multiplied by other terms including y, including the derivatives, and third thing, we should not have the transcendental functions including y, right. So, if all these conditions are not there in our differential equation, then we call that to be linear. Otherwise, if any of the condition is violated, in that case we call our differential equation to be non-linear, and there are very few methods available to solve these non-linear differential equations. So, our focus would mainly be on the linear differential equations of this kind, right. So, this would be more clear through examples. So, here you can see in the case of linear equations, you have the second order derivative whose power is 1, then we have the first order derivative whose power is 1, and then we have the power of y to be equal to 1, right. So, this is linear equation. Similarly, in the second equation which is written below this linear equation, here in this case we have the fourth derivative, third derivative, first derivative of y. However, the terms x square, x cube are multiplied to it. So, it does not matter if we are multiplying the x terms to the derivatives of y or y itself. And moreover, on the right hand side you have e to the power x, which is the transcendental term in the independent variable. So, independent variable does not cause any harm here. So, in this case, this equation is a linear equation. Talking about the nonlinear equations which are listed here above, right. So, in all of these equations, in the first equation below nonlinear part, you can see we have y square term. So, because the power here is 2, so therefore, the equation here is nonlinear. In the second equation, we have dy by dx power 3. So, that means this equation is also nonlinear in nature. And in the third case, we have a term dy by dx where y is multiplied to it. So, we have the product of y and its derivative. So, this is also a nonlinear term available with us. Another classification includes homogeneous differential equations and non-homogeneous differential equations. So, the homogeneous differential equations are those equations where the right hand side of the equation is 0, and non-homogeneous differential equations where the right hand side is not 0. So, we have some terms available on the right hand side. So, these are the clear distinctions of homogeneous and non-homogeneous terms. Next, we have the classification as linear differential equations which are linear with constant coefficients, and differential equations which are linear with variable coefficients. So, in this case, in the first case, you can see on the left hand side we have the coefficients of d2y by dx square as 1, the coefficient of dy by dx as 5, and the coefficient of y as 6. So, these all are constants. So, therefore, this equation is linear with constant coefficients. Why linear? Because the power of each of these terms is 1, right. And when we talk about linear equation with variable coefficients, in that case we have, if you see the coefficient for the term d power 4, d4y by dx4, its coefficient is 1. The coefficient of d cube y by dx cube, it is x square, and the coefficient of dy by dx, that is x cube. So, here you see the coefficients are variable in nature because x here is the independent variable. So, this is another classification. So, based on these classifications, what we can do, we can identify the differential equation into a certain class of differential equations, and then based on that particular class, we can select a particular method which are available to solve such kind of differential equations, and then based on that particular method, we will solve our differential equation. So, in short, we in this lecture we have learnt about differential equation. We introduced ourselves to differential equations. We learnt about differential equations, what are these, why do we need them, and we also saw certain real life examples. And lastly, we have also learnt about the classification of differential equations. So, based on this classification, we can identify different methods, and then we can apply those methods to solve differential equations. Well, that is it. Thank you for watching.